Quantum Physics, Lesson 1, Atomic Notation. Today's purpose is to learn how to write the isotopic notation for ions. The relevance is that we will be using this technique to write equations for fission and fusion reactions, a lot like a chemistry equation. Success. When given a description of an atom or an ion, I'll be able to write the notation for it. Atoms. Atoms are named nitrogen or oxygen or anything else according to the number of protons. You will find the number of protons by the whole number in each box of the periodic table. So if I look over here, I can look at the Be, and the whole number here is 4. So that's the number of protons in a beryllium atom. And over here with Li, that's lithium, the whole number is 3. So there are 3 protons for every lithium atom. Technically, for something to be called an atom, it must be neutral. So there will be an equal number of protons and electrons. So going back here to the beryllium, if there are 4 protons, then there will also be 4 electrons in a normal beryllium atom. For lithium, there'll be 3 protons and 3 electrons in a normal lithium atom. Ions are atoms of the same element but with different number of electrons. If an atom has extra electrons, it has a negative charge. That means it has more negative electrons than positive protons, and so there's a balance. If it has more protons than electrons, then it has a positive charge. In this chapter, we'll be discussing charges in terms of unit charges, or chemistry units of charges. Isotopes are atoms of the same element with different numbers of neutrons. Every element comes in a variety of isotopes. The average number of protons and neutrons for an element is approximately the decimal number in the periodic table. You will find the most common number of protons and neutrons by rounding the decimal number in each box. That doesn't always work, but it commonly works. It's close enough for our uses here in this class. The notation for different isotopes follows this pattern. In the center, you have the chemical symbol. That is the letter or 2 letters from the periodic table that stand for that element. The top right is the net charge. You take the number of protons and the number of electrons and you find the difference and you put the net charge up there. It's a positive difference if you have more protons than electrons. If there are more electrons than protons, then the net charge will be negative. In the bottom right-hand corner is the number of neutrons. Bottom left, number of positive things, normally protons, but we will learn some exceptions to that rule later on in the chapter. And then the top, the total number of nuclear items, which is usually going to be the number of protons and neutrons. So, letter A. What is the notation for a nitrogen atom with 5 neutrons and 2 extra electrons? Okay, so I'm going to put the capital N in the middle for nitrogen. That's from the periodic table. And it says here as 2 extra electrons. So that means 2 more negative electrons than normal. 2 more negative electrons than positive protons. So that's going to give it a charge of -2. Number of neutrons is in the bottom right, and the story problem tells us that there are 5. Number of positive things, which in this case will be protons. And we're looking at the periodic table. The N here has a whole number of 7 on top. So there are 7 protons. The only exception to protons is when we deal with antimatter, and we'll be discussing that later on in the chapter. And then in the top right-hand or top left-hand corner, it says total number of nuclear items, which again, with the exception of antimatter is just simply going to be protons plus neutrons. The 7 plus the 5. And so we get 12. And that is the isotopic notation for letter A. Letter B. What is the notation for a lithium atom with 2 neutrons and 4 total electrons? So lithium from the periodic table is Li. That's in the upper left-hand corner here. And it says here that it has 2 neutrons. So that goes in the lower right corner. Let's see here. I'm going to jump to the left side at the bottom. The total number of positive things, which would be protons. And the periodic table has the Li with a 3 above it. So that 3 is the number of protons. That's the positive stuff here. In the upper left corner is the total nuclear items, which is going to be the protons plus the neutrons for a total of 5. Okay, now it says here that it has 4 total electrons. If there are 4 negative things and 3 positive protons, the balance of that is going to be -1. One more negative thing than positive things. There's your answer for letter B. Letter C. What is the notation for a carbon atom with 6 neutrons and 5 total electrons? So the carbon has a C, capital C as a symbol, and according to this periodic table, the C is here, and it has a positive 6, the whole number 6 there. So that tells me the number of positive protons. 6 will go in the bottom left. The story problem says we have 6 neutrons. So I'm going to put 6 down there. The total number of nuclear items, total number of protons plus neutrons, will be 12. And it says here in the story problem, 5 total electrons. If there are 5 negative electrons and 6 positive protons, the balance there is going to be 1 more positive proton than electrons. So we have a +1 charge. And that is your answer for letter C. Letter D. What are 2 ways to show an individual proton? You have a little lowercase p for proton, and the net charge on that is a +1. If we have a single individual proton, then we have 1 proton. We put a 1 in the lower left. If I only have a proton in my hand, I have 0 neutrons. And so I put a 0 in the bottom left, or bottom right, I should say. The total number of nuclear items, then, is the number of protons plus neutrons, which is still 1. So that's one way of showing an individual proton. But normally, in reactions, we just simply put a P+. Letter E, 2 ways to show an individual electron. So a little letter E. The net charge is -1. The number of neutrons in an electron is 0. The number of protons in an electron is 0. And the number of nuclear items inside an electron is, again, 0. An electron is not a nuclear item. It's not in the nucleus of the atom. It is going around the nucleus in the orbits outside of the nucleus. The other way of showing electron is just simply an E with a minus mark. Letter F. What are 2 ways to show an individual neutron? A lowercase n for neutron. The net charge is 0. There is 1 neutron in a neutron. There are 0 protons in a neutron. And the total number of nuclear items, adding up protons plus neutrons, gives me 1. So that's one way of showing it. The other way is just simply to have an n with a little 0 up there. And that is the end of lesson 1.